Hi guys, today we will continue our discussion about molecular biology, and today's topic is metabolism of purines and pyrimidines, nitrogenous bases. As we talk about purines and pyrimidines before, they contain from rings. When we talk about purines, they contain two rings, whereas pyrimidines contain only one ring, and purines contain um, within these rings amino acid that you have to memorize. And this amino acids is glycine, aspartate, and glutamine. We have mnemonic for this amino acid is um, Cas pure until they gag, and gag stands for glycine, aspartate, and glutamine. Cas pure is purines. Okay, and now we'll discuss how these rings are formed. And first, we will talk about our summary table about synthesis of purines and pyrimidines. Both of these pathways use de novo synthesis as well as salvage pathway. Today, we will talk about de novo synthesis, but when we talk about purines, they use salvage pathway mostly, whereas pyrimidines use de novo synthesis. And synthesis processes is comparatively complex for purine synthesis. Also, we not have to memorize all of its steps, and it's much simpler. It looks bigger because we have to memorize all of the steps. It relatively smaller. That's why it's high yield for using to know all of the steps. And intermediate products is important because they use similar, like the same substrate as PRPP, and they divide it to IMP and UMP, and depending on what intermediate product will form, they will produce particular products. And from IMP, purines will be formed, and from UMP, pyrimidines will be formed. Glycine, as was said, used to form purines, and it does not use to form pyrimidines because pyrimidines use only aspartate, as was said, and for purine synthesis, we have GAP mnemonic. It is glycine, aspartate, and glutamine. So here you can see the novel synthesis of purines, and we say that PRPP synthetase is rate-limiting enzyme for both purines and pyrimidines because, as I said, they use the same uh, first substrate, and it will form PRPP from ribose 5-phosphate, and ribose 5-phosphate comes from HMP shunt. And why we call this step or this enzyme rate limiting? Because it will determine the rate of this reaction. So if there's a lot of products will be formed, we don't need to form more products. Therefore, this um, products will inhibit this enzyme and will slow down this reaction. And when we don't have enough products, when we have relatively smaller amount of products, it requires to be more product to form. That therefore they will not inhibit this enzyme, and the rate will be faster. When we talk about purine synthesis in particular, rate limiting step is PRPP aminotransferase because intermediate products such as IMP, AMP, and GMP will inhibit this step. And although we don't have to memorize this huge 9 steps to form IMP, we have to know that in this way where from PRPP will form IMP will be a high yield amino acid will be added. It is glycine, aspartate, and glutamine will be added at this time. You have to know that aspartate, glycine, and glutamine, as well as folic acid, tetrahydrofolate, will be used in this steps and will be incorporated into two rings to form purine. And you have to know high yield drugs that will inhibit this processes. For example, 6-mercaptopurine as well as its product azathioprine will inhibit de novo purine synthesis at this step. And it actually, we have to know that azathioprine is metabolized via purine degradation pathway and lead to immunosuppression when it administered with xanthine oxidase inhibitor. Here, formation from IMP, GMP, we inhibit by drugs mycophenolate and ribavirin. This inhibit inositide monophosphate dehydrogenase. And now we will discuss about pyrimidine synthesis. For pyrimidine synthesis, as I said, we use also PRPP. This is similarity between these two pathways, but the main substrate is orotic acid, and we have to know how orotic acid will be formed. And orotic acid will be formed from carbamoyl phosphate. Carbamoyl phosphate will be formed de novo or from urea cycle. We talk about de novo today, and de novo will be formed from adding glutamine, CO2, and ATP, and glutamine will be a substrate for nitrogen here. And for production of carbamoyl phosphate, we use an enzyme called carbamoyl phosphate synthetase 2, and carbamoyl phosphate synthetase 1 is used in urea cycle. Here you can see urea cycle, which is in the liver, particularly in the mitochondria, is adding up bicarb, ammonium, and two ATPs, and form carbamoyl phosphate using enzyme carbamoyl phosphate synthetase 1. And you have to know that nitrogen source is ammonium here. Here's summary table for carbamoyl phosphate 1 and 2. Carbamoyl phosphate 1, as we said, is used in mitochondria, in the liver, as we said, but in the kidneys as well, but liver is the main location, and substrate of nitrogen is NH4. And here we say about carbamoyl phosphate 2, it is de novo synthesis. It occurs in the cytosol in a variety of tissues, and source of nitrogen is glutamine here. So from carbamoyl phosphate we form orotic acid, and we have to memorize it in this step. This high yield amino acid will be added, which is aspartate, the only amino acid that will form its ring. So orotic acid will convert to UMP, UMP will convert to UDP, UDP will form DUDP and CTP, and DUTP will form DUMP, DUMP will form DTMP. This path is high yield because we have to memorize this tamidil synthase will be inhibited by 5-fluorouracil as well as with capecitabine. And we have to know that to form DTMP from DUMP, we have to use tetrahydrofolate, right? Its active form called N5N10 methylene tetrahydrofolate, and it will convert DUMP to DTMP, and it will be converted to dihydrofolate, and we have to reuse it, and therefore we use dihydrofolate reductase and we reduce it to tetrahydrofolate form, and then tetrahydrofolate will again be activated and form N5 and 10 methylene tetrahydrofolate, and it will happen again and again. And we have to memorize this enzyme, that dihydrofolate reductase, which will be inhibited by methotrexate, TMP, SMX, we know that drug, and with pyrimethamine. Pyrimethamine is anti-protozoal drug, yes. And carbamyl phosphate conversion to orotic acid will be inhibited by leflunomide, and leflunomide will inhibit dihydroorotate,